We've been working on this project for quite a while now, and in my career as a structural engineer and in my firm's career as mechanical, electrical, plumbing engineers, we've come across a lot of projects that have looked at modular. And modular means a lot of things for different projects. And what's unique about this project is the extent to which we take the modular pre-construction and do as much of the module work in the factory as possible. I like to say that the building is built of standard building components that are assembled in a creative way to facilitate an innovative and efficient construction process. So the building is designed to the same codes and standards and uses the same systems that most every structural system in New York City actually uses. So the standard lateral system of a building is kind of the backbone of the building, and that's what resists wind and seismic loads. And the lateral system in this building is a brace frame, just like every office tower in Manhattan, practically, of a similar height. The modular system is designed to the same New York City code that every other tall building and every other building in New York City is designed to. And also, just to give both the client, Forest City Radnor, confidence and the DOB confidence in the structural system, we've had an independent structural peer review by a well-known firm here in New York City. They've taken a look at the design, the calculations, and run independent verifications to ensure that the safety and stability of the building is true. And secondly, we've done a number of tests to verify the performance of this building, including the wind tunnel testing, where we actually take a small-scale model of the building and put it in a wind tunnel and to get a better understanding of how it interacts with the wind and to confirm the wind loads that are normally derived through code calculations. This shows an elevation on the front of the building, and it explains what portion is modular and what portion will be constructed like a regular building. So everything below the red line will be built just like every other building in New York City. It'll have, the hole will be dug for the excavation for the basement. It'll have a concrete substructure and foundations put in. And then the ground floor level will actually be framed with stick-built steel, just steel beams and concrete floor slabs. And then on top of that, we'll have a steel platform that's, again, a grillage of beams. And that becomes the platform that we come out and then start stacking the modules on. And so everything above that red line is what we call the modular part of the construction. The basic backbone or chassis for the module is shown on the screen here. It's effectively a way to break the building down into shippable size pieces. So each of these modules, and the building has been broken up in a way to effectively make sure that the width of the building across here is no more than 15 feet, and the length of the module can vary anywhere from 20 to 50 feet. Typically, they're around 30 feet. This is to make sure that the modules can be shipped on city roads, like a wide load, but it's not a road closure style wide load, which if it was any wider than 15 feet, it would have to be. The module is very stable on its own right. It's like a box. You set the box down, and it's just like a block, and it's very stable on its own right. We stack these modules up to create the building, and then we tie them laterally back to the brace frame system, which I'll show you in a minute. The module actually spans between the four corner columns, which you can see here. And then wherever we have the ability to put diagonal bracing in, we put bracing on the side of the modules. And that makes the module very efficient structurally. But in many instances, we can't put the bracing on the side of the module because, as Chris showed, there's a lot of instances where we have a room that passes through the side of the module or a hall that passes through the side of the module, like we have shown in the back of this module here. So in this case, within this module, we could have a living room and a kitchen, and then the module next to it would have, say, a bedroom and a bathroom. And you'd have the door to go from the living room into the bedroom right here, and then this could be a link to make a bigger living room in some instances. In areas where we don't have a connection across the side, we put in as much diagonal bracing as possible. All of the module framing is steel. Once we get above that line that goes to module construction, we have no concrete. So once you get above the ground, there won't be concrete trucks on the site, and we'll get into that in a bit more detail. This shows the overall system. So everything that's in gray, and I've shown kind of an indicative modular layout on this side. Everything that's in brown and gray, or gray there, is actually modular construction. So it's just these modules stacked one on top of another and tied laterally together. The brace frame system, which you can see in red above, is the backbone to the building. All the modules get set one level at a time. They're connected together at the roof level and tied back into those brace frames. So the brace frames act like the skeleton of the building, while the modules themselves carry their gravity loads down to the ground. The stuff below the plinth line and below that red line we have shown in red and in the concrete construction for the substructure below, and that's all site-built, normal construction. And we also show the transfer over the Dean Street Arena entrance. This is a complete rendering of the entire structural system for B2. You'll never actually see it like this, as Bob Santa will explain in a minute. The modules come out and you never actually see the structure of the modules because they're fully finished when they're brought out to site. So you'll never actually see this image, not like a lot of projects in town where you see the steel frame going out first and then the facade goes on and then the finishes come on later. This one will come out and the building will look pretty much complete each level that they're stacking. So with that, I'd like to introduce Bob Santa. He's the head of construction at Forest City Renter.